This is another tiny little video on how to use the Excel spreadsheet that computes crustal strain in a triangle between 3 GPS stations. These URLs that you see here will lead you to the Excel spreadsheet in question and an explanation of its output. So without further ado, let's take a look at it. So this is one that was put together more or less for the GETSI project, and it's a collaboration between Phil Reeser and Beth Pratt-Sitchwalla and I primarily. But at any rate, the yellow cells here have the input positions for the data that we collected from UNAVCO. The site names, the 4-letter descriptors, longitude, latitude, east velocity's uncertainty, north velocity, and the north velocity uncertainty. Now I've already put in 2 sites worth of data, and we're going to see about putting in the third site bit of data. So where did the data come from? Well, you may recall that we took a look at a CSV file that has the reference position of a given site in it. And so we're going to put this latitude and this longitude in there. And we also then collected some velocity data. And so we're going to be putting in the east-west velocity and the north-south velocity and their uncertainties. So let's finish off this data set. So we're going to label this P150, and we're going to put in the longitude and the latitude and the east velocity, and its uncertainty is 0.07, and finally the north velocity, and its uncertainty, 0.03. Now as soon as I type this digit in, it will have computed all of the output that we need. Over here is a strain ellipse exaggerated by about 1,000,000 times, and the initial shape was a circle, and that circle, given the crustal strain that we're measuring with the GPS velocity data, will evolve into this red ellipse. So the radius in this direction seems to be less. The radius in this direction seems to possibly be a little bit more. Over here in the blue cells, we've got all of our output data, the translation vector, the rotation, maximum horizontal extension, minimum horizontal extension, the maximum shear strain, and the area strain are the big ticket items that I tend to be interested in. A little deeper under the hood, we've got the Lagrangian strain rate tensor, the first invariant, second invariant, and third invariant. Oftentimes we use the second invariant in contour maps of strain over a broad crustal area. So these are all important numbers. Exactly what those numbers mean? Well, take a look at the accompanying document that explain the output of this process. And that's the lower of the 2 URLs that you see on the screen. So that's all we've got on this topic.